Welcome once again to Fame Global Academy, an academy where we learn beyond boundaries. And for those of us who are just joining for the first time, viewing for the first time, this is a section where we are equipping children, students who are preparing to write their forthcoming JAMB for 2026 section. So, and I'm my favorite physics teacher, Fred Mark. So follow us closely and learn more. Okay, our first question this morning is from JAMB 2014. We're going through past questions as far back as 1996 till date, 1999, and so on, 2010. We are going through them, picking them one after the other to equip you for this forthcoming JAMB exam. Now, first question this morning is from JAMB 2014, question 2. JAMB 2014, question 2. It says a quantity which requires a receptive magnitude. A quantity which requires a receptive magnitude and direction to be specified is A, we have temperature, B, we have distance, C, displacement, and D, mass. If you are watching, I think I could perceive your answer. Okay, if you are choosing A, your answer is wrong. Remember, we have scalar quantities and vector quantities. Now, scalar quantities are quantities that has magnitude, but they do not have direction. While vector quantities are quantities that has both magnitude and direction. And not just direction now, is specified. Now, so if you are saying temperature is wrong. Temperature is a scalar quantity. It has magnitude, it does not have direction. If you are choosing B, also B is wrong. B is a scalar quantity. It has magnitude but no direction. If you have chosen D, D is also wrong. D is a scalar quantity. It has mass but no direction. Now, displacement is the correct answer. So the answer is C. C is the correct answer. Displacement is a vector quantity. It has magnitude, it has direction, not just only direction, has a specified direction, showing you the distance of an object, the direction is going, whether it's northwards, whether it's southwards, it's being specified. So the answer to this question is C. Displacement. Displacement is a vector quantity. It has magnitude and it has direction. Okay, let's go over to question 2. Question 2. Question 2 is still the same question from JAMB 2014. JAMB 2014, question 7. If you check, you'll see question 7 in same year, JAMB 2014. So a car accelerates uniformly from rest 3 meters per second square. Its velocity, okay? Its velocity a distance of 24 meters is A, we have 12 meters per second, B, 144 meters per second, C, 72 meters per second, and D, 36 meters per second. Now, Question 2 is still from the same year, 2014. Question 7. A car accelerates uniformly from rest 3 meters per second square. Its velocity after traveling a distance of 24 meters is, in other words, we are asked to find the velocity after it has traveled a distance of 24 meters. Now, first of all, is the solution. We write out the parameters. What are we looking for? What is given to us? Which formula do I now use? And what is now my SR unit? I remember I told us in my previous classes that SI unit is very important, formula is very important, symbol very important, definition also very, very important. Now understand the question. It says a car accelerates from rest. In other words, which means your U, which is your initial velocity, is 0 because it is starting from rest. It is starting from rest. Once the body is starting from rest, the velocity of that body initially is 0 automatically because it is starting from rest. So U is equals to 0. What else is also given? We are given A, acceleration. A is equals to 3 meters per second squared. What is also given? Distance, which is S, is also given as what? 24 meters. I am asked to find V, is unknown. V is unknown. Now, remember, we have various major 4 equations of motion, but I'm going to be dealing on 2 for now. For V is equals to U plus AT, that's 1. Another one is V squared is equals to U squared plus 2AS. Look at these 2 formulas. Preferably, I am supposed to use equation 2. 1, I'm asked to look for V, very correct. I'm giving U, very correct. I'm giving A, which is acceleration, but I'm not giving time. So this formula does not suit this question. Equation 2, I'm asked to find V, okay? And I'm giving U as 0. And I'm giving A, which is acceleration, as 3 meters per second squared. I'm only giving distance as 24 meters. So this equation 2 is the best suitable for this equation. Yes, 1 and 2, I'm asked to find velocity, but I am not given time. And so this equation does not go. So I should use equation 2. So using the formula, V squared is equals to U squared plus 2AS. V squared is equals to U squared plus 2AS. Now, all I need to do is to impute all this into this formula. So let's go. I have V squared is equals to 0 plus 2 times 3 times 24. V squared now is equals to 2 times 0 is already gone. So 2 times 3 is 6 times 24. Remember, I have not asked to find V squared. I'm asked to find V, not the square root of not the square of velocity, but I'm asked to find the velocity, a single entity. So V is equal to the square root of 6 times 24. Square root of 6 times 24. Mathematically, if I'm asked to find V and move this square to this other side, it becomes 6 times 24, which is V is equals to 144. 144. If I multiply 6 times 24, I have 144. And if I find the square root of 144, V becomes 12 meters per second. So if that's the case, so A is now the correct answer to that question. I come again. A car accelerates uniformly from rest at 3 meters per second square. Its velocity after traveling a distance of 24 meters is A is 12 meters per second, B is 144 meters per second, C is 72 meters per second, and then D is 36 meters per second. So I say, first of all, is to write out the parameters. What am I giving? I'm giving U at 0 because it is starting from rest. So automatically your initial velocity becomes what? 0. And A is given in the question as 3 meters per second square. S is also given as 24 meters, and I'm asked to find velocity. So I said we have two different formulas to find velocity. But the first one is V is equals to U plus AT. It does not equate to the question because I'm not given time. But in the question 2, which is V squared is equals to U squared plus 2AS, is a perfect formula to this because I am given acceleration and I'm given distance. I'm equally given initial velocity as U. So it's to impute all those things into the formula, which is V squared is equals to U squared plus 2AS. 2AS. So if I 0 now plus anything, it becomes a number. So 2 times 3 is 6. 6 times 24, I have 144. If I find the square root of 144, I'm having 12 meters per second. Remember, you have just 1 minute to answer this question. All the questions in JAMB, you have just 1 minute for every question. So what you do is to read the question and understand it as fast as possible, and then input the formula and then just solve directly. Okay, I think we are done with that. So question 3. Question 3. I believe we are gaining something from this class. Question 3 is still on okay. Question 3 is still on JAMB 2014, question 8. JAMB 2014, question 8. Say calculate the escape velocity. Calculate the escape of a satellite launched on the Earth's surface if the radius of the Earth is 6.4 times 10 to the power 6 meters. I have 5.3 kilometers per second. And then we have B 4.2 kilometers per second. Then C we have 4.0 kilometers per second. And then D we have 113 kilometers per second. Now, question 4. Yes, question 4. 1, 2, 3. Okay, question 3. Now, the same JAMB 2014 was question number 8 in the JAMB past question. Calculate the escape velocity of a satellite launched from the Earth. Launched from the Earth's surface if the radius of the Earth is 6.4 times 10 to the power 6 meters. Then the options are A 2.5 kilometers, then B is 4.2 kilometers per second, C is 4.0 kilometers per second, and then D we have 11.3 kilometers per second. Now, first and foremost, what is given? What is given? So solution. So what I'm given I'm given r, which is the radius of the earth, as 6.4 times 10 to the power 6 meters. I'm equally given g, which is 10 meter per second square. And then I'm asked to find v, not just v, the escape velocity. Escape velocity. Now, radius of the earth is given as 6.4 times 10 meters, 3.4 times 10 to the power 6 meters, and I'm given g. I'm not given, but I should know that g is a constant value. That is, the gravity of the earth, acceleration due to gravity, is 10 meter per second square, is a constant value. You don't look for it. It's always given. If it's not given, you should know as a student that acceleration to gravity, which is small g, is always 10 meter per second square, or 9.8 meter per second square, as the case may be. Is 10 or 9.8 meter per second square. It is a constant value. Now I'm asked to find v, which is the escape velocity. The formula for escape velocity is v is equal to the square root of 2gr. 2gr. Now, this is the formula for escape velocity. V is equal to the square root of 2gr. Having known that, remember I said we have various different formulas in physics, as many as you can cram, as many as you can put in your memory, put them. Because on exam day, all you need to do is just to input those things you have known into the formulas. Put your formula into the input your parameters that have been given to you into your formula. So if you have enough formulas in you, you should be able to remember and pour it out on that day. So as many formulas as possible, because in JAMB questions they are going around all what you have done from your SS1 to SS3. So all the formulas you have learned so far, do yourself the best thing you can do is to memorize as many of them as you can memorize, and then all you need to do is to input your parameters into the formula. Now in this question, now we're given radius of the earth as 6.4 to power 6 meters. I'm giving g as 10 meter per second square. It's not given, but I should know. Now v is escape velocity. Now escape velocity has formula as v is equal to the square root of 2gr. Remember, we have velocity of motion, which we have just done, which was v is equals to u plus at. They are both velocity, but in this case is the velocity of the earth, the escape velocity of the earth, the slightest velocity, speed that the body can leave the earth's atmosphere. So v is equal to the square root of 2gr. So all I need to do is to impute it. Now 2 times g is 10 times 6.4 times 10 to the power 6 meters. If I multiply this, I will have v. Use a formula to multiply. You're having v is equals to if you multiply directly and then find the square root. Multiply directly 6 times 2 times 10, 20, 20 times 6.4 to the power 6 meters, and then find the square root of it. You're having 11313.7 kilometers. Sorry, is in meters. 113. When you multiply this 2 times 10 times 6.4 to the power 6, and then find the square root, you are having 11313.7 meters. Now remember, the velocity for the earth has an SI unit as kilometer per second. So what I need to do is to convert this to kilometers. So I'm dividing by 1000. If I divide this by 1000, I'm having 11. So v becomes 11.3137 kilometers per second. So approximately becomes 11.3 kilometer per second. So question The question number 8 in 2014 JAMB, the answer is D, 11.3 kilometer per second. 11.3 kilometer per second. Remember I said the escape velocity of the earth has a formula as V is equals to 2gr. So input it into the formula. I'm giving V as, V is, I'm looking for V. G is equals to 10 meter per second square. The arrow is 6.4 times 10 meters. 10 times 10 to the power 6. If I multiply together and find the square root, I'll be having 113.7 kilometers. Meter. If I convert it to kilometer, because the SI unit is in kilometer per second, if I convert, I'm having divided by 1000, I should be having 11.3137 kilometer per second. Approximately, because the next number is not up to 11.3, the next number is not up to 5, so I can write it up to 1, so it becomes 11.3 kilometer per second. So this D becomes the answer to this question. D becomes the answer to this question. Okay.